Hi students, MCQ number 19. A charge capital Q is divided into two parts and they are placed at a fixed distance. Okay. The force between the two charges is always maximum when the charges are. So we have to find the magnitude of the two broken parts of the given charge capital Q. So I will take that the two charges are small q and capital Q minus small q. So I break a larger charge into two parts. If I add q plus capital Q minus q is what again? Capital Q only will come. So let small q and capital Q minus small q be the two charges. Now the force between the two charges is equal to 1 by 4 pi epsilon naught into Q1 into Q2, that is Q into capital Q minus Q divided by d square. So this is 1 by 4 pi epsilon naught is what? K, is it not? So this is K divided by d square into Q into capital Q minus Q. So this K is a constant, d square is a fixed distance, so it must be a constant. So this K by d square is some other constant, okay, some other constant. Say for example C I will take, C is another constant. So C into Q minus small q. Therefore this is the expression for the force between the two parts of the given charge. Now what is given? The force between the two charges is always maximum. That means for maximum force, okay, for F maximum, the differentiation of the force with respect to the charge dq will be equal to 0. So this is the condition which is to be satisfied for the maximum force between the two given charges. So in this equation, force F is equal to constant C into small q into capital Q minus q. Differentiation of this force with respect to the charge small q is equal to 0. So this is the first equation. I am going to differentiate on both sides. Okay. So what I will get? dF divided by dq. So this is equal to, constant is taken outside, constant, okay, into d by dq of q into q minus q. So q into q. So this is d by dt of q into q minus q. So this is once again equal to what? A constant C into d by dq of, okay, d by dq of, so small q capital Q minus q square, okay, like this also I can write. So once again this is equal to constant C into, so d by dq of q capital Q is capital Q, okay, minus d by dq of q square is 2 small q. So this df by dq is equal to C into capital Q minus 2 small q, and this must be equal to what? 0. Is it not? So capital C, the constant, into capital Q minus 2 small q. This product must be equal to 0. Now C is a constant, positive constant. It cannot be 0. Is it not? C is not equal to 0. Because what is C? C is equal to K divided by d square. K is always greater than 1 and it is 9 into 10 power 9. D square is again what? For a fixed distance it is also a constant. So it cannot be 0. Therefore only chance is what? Capital Q minus 2 small q must be equal to 0, or 2q is equal to capital Q and Q is equal to what? Q by 2. Capital Q by 2. So, we took the two charges as small q and capital Q minus small q. So, the value of small q is equal to capital Q by 2. Therefore, the other charge is capital Q minus small q. So, this is equal to Q minus Q by 2. That is also equal to what? Q by 2. Therefore, the two charges must be what? Q by 2 and Q by 2. Okay, so the two broken parts will have a maximum force at a fixed distance, means both should be having the same magnitude. That is the answer we are getting. So the option A itself is the correct answer. Q by 2 and Q by 2. Okay, therefore option A is the correct answer. Okay, I hope you must have understood well. Fine.